Hello there, Mr. Sutton bringing you a lesson on polar complex numbers. In this one, we'll be converting between polar and rectangular forms for complex numbers. We'll also be multiplying complex numbers in polar form. For your warm-up, go ahead and convert this rectangular point to polar form. Alright, let's see how that went. So for radius, we need the square root of these two things squared and added together. Basically Pythagorean theorem. So that'll be 4 times 3, which is 12, plus 4 comes out to 16, and the square root of that will be 4. For the angle, we need inverse tan of y over x. So let's plug that in our calculator. And be careful when you do this. This 2 and radical 3 need a parentheses in the denominator on the calculator, otherwise the order of operations gets messed up. So that should come out to 30 degrees. Let's compare the quadrants now. The original rectangular point is in quadrant 1. The angle here also quadrant 1, so we can keep the angle. That'll just be 4, 30 degrees for the answer. Now that we've talked about rectangular and polar form for real numbers, let's deal with complex numbers. Recall that the complex number plane has a real axis, which is kind of like the x-axis, and an imaginary axis, which is kind of like your y-axis from before. And we graph complex numbers with arrows. So for example, instead of putting a point at a comma b, we draw an arrow to a plus bi. A is your real number, and bi, that's your imaginary number. So now the rectangular form of a complex number is this right here. This is what you learned before. This is a plus bi. Again, a is kind of like an x value, b is kind of like a y value. There's a polar form for that now. To see what it is, we need to take a few more measurements here and get a new perspective on things. Instead of even looking at the a and the b, we can think of this arrow here as having a length, a radius, if you will. And you could also think of it as kind of the hypotenuse of a triangle. Now, this radius here also has an angle, and to figure out what that angle is, or to figure out these other sides, a and b, in terms of radius and theta, this bottom side, this is just going to be your radius times the cosine of that angle. And this b value here, this height, that's just going to be the radius times the sine of the angle. This is kind of like when you had x equals r cosine theta and y equals r sine theta from the last lesson. So instead of writing a plus bi, we could instead write r cosine theta plus r sine of theta times an I. And we don't have to write it like this. This is a little bit bulky. We could factor an r out from all that. So that would be r outside, cosine and I sine theta inside. And there's actually another way we could shorten this. I put some letters in red here. A lot of mathematicians actually write this as just r and then cis theta. And this is a shorthand for the radius. CIS, that's just cosine, and then plus I times sine, and there's your angle. Now how do we find the radius and the angle if we start with a and b? So we've got a radius, that's just going to be basically x squared plus y squared. In this case, that's a squared plus b squared, because those are really sort of like x and y. And then for the angle, normally before we had inverse tangent of y over x, this time we have inverse tangent of b over a, but it's still rise over run. Now that we've seen what polar form of complex numbers looks like, let's take this rectangular complex number and make it a polar complex number. Now the good news is this is kind of like converting from rectangular to polar real coordinates. Everything is basically the same as before, but now instead of x and y, we're using a and b. And instead of putting your answer in r comma theta form, our answer goes in r cis theta form. Everything else is the same though. So now we're going to start with our radius. This time that's going to be square root of a squared plus b squared, basically x and y again. So when we did this on our warm-up with these exact same numbers, we had the square root of, this was 12 plus 4, so 16. Gave us 4 for the radius. And now we're going to find the angle. That's inverse tangent of b over a instead of y over x. So that's going to be inverse tangent of 2 over 2 radical 3. But when we did this on the warm-up, what did that come out to? Oh yeah, 30 degrees again. So comparing our quadrants, 30 degrees, yes, that's quadrant 1. 2 radical 3 plus 2i is as far as you could assign quadrants to the imaginary axes. This is basically quadrant 1. We've got positive and positive. So we're going to keep our angle, and we're going to write this as 4 cis 30 degrees to put this in our cis form. Now that we know how to go from rectangular to polar form, how do we get back to rectangular form? The good news is RCis has this built right into it. To get rectangular form, you just have to expand RCis form. Now remember, that was just r times the cosine of theta plus I times the sine of theta with an r in there. So we have r cosine of 230 plus, and that's 8 cosine of 230, plus 8 sine of 230 times I. And we just have to figure out the cosine and the sine of 230. So 8 times the cosine of 230 is negative 5.1. And let's use sine instead of cosine now for the other one. That comes out to negative 6.1. So we have negative 5.1 minus 6.1 I. All right, pause the video and try this one out. Let's see how you did. So expanding that, we've got 2 cosine of 135 plus I times the sine of 135, and then an I. Cosine of 135, that's like 45 degrees in the second quadrant, so that's going to be negative radical 2 over 2, but that cancels out with this 2 here to give us just negative radical 2. And then over here we've got 2 times positive radical 2 over 2, so negative radical 2 plus positive radical 2i, and that's our final answer. We'll do one more problem type here. We want to multiply these polar coordinates together. So to do this, very simple, you just have to multiply the r's and add the thetas. So this one, for example, 2 times 3 would give us 6, 115 plus 65 is 180, so we would have 6 cis 180. Pause the video and try this other one. So 4 times 3 is 12, and then 45 plus 90, that's going to be 135, so 12 cis 135 degrees. This concludes our second lesson on polar coordinates. Till next time, this is Mr. Sutton signing off.